welcome to the RPS project. My name is Richard and today I'm going to be looking at, what's that you're probably asking, this scraggy little strip board. Well, actually what it actually is it's a little Class A amplifier that I put together quite some time ago when I didn't really understand what a transistor was doing. And I definitely didn't know how to bias it up, and I made this little circuit up, saw it on the internet, thought I'll try that, see what happens, and it didn't really work very well. So I've decided to have another look at it and find out where I've gone wrong. I think this is great to do actually if you've done something in the past and it doesn't work and you want to know what you did wrong. Go look at these old circuits, especially if you've improved your knowledge in, let's say, quite some time, maybe several years later, and then you look at it and you go, that's where I went wrong. So it's a great learning aid, I think, looking at your old mistakes. So let's get it on the bench and have a look at it. So here we have our little transistor board set up. It's got 3 transistors and, well, why 3 transistors? To be quite honest, I don't know why I put 3 transistors in there. The diagram I got from the circuit I got from the internet showed 3 transistors, but it didn't show any of the values of any of the components, so I was a bit stumped at the time as to what I should be putting on there. So I just bunged in a bunch of stuff that I thought would work, and it didn't really work. What I've really got is actually that. Now, let's get a pointing stick. A little bit of pointing stick than that, this will do. Got an input, 9 volt supply, I think that was the consideration, 9 volts, way. So it worked with I suppose with a 9 volt battery. BC337, not once but twice, and then effectively this is ZTX651 as like an emitter follower type circuit. Why the 2 transistors I don't know. Perhaps it was considering that I was going to be amplifying at a really low, very weak signal. Perhaps that was the consideration then. So can't tell you why other than that. Now when I've looked at this and I've gone, right, okay, I've got 4K7 and a 4K7 there, sorry, a 1K there. Is this biased up quite well? Well, actually it is. That's not bad really. I think, if I remember rightly from my doodlings that I get, it should be something around about 1.6 volts in there onto the base. It's around about what it is, with about, I was hoping for about 1 volt, but I think it's nearer to 0.9 of a volt is what I've got on the emitter. And it's the same on both, which seems okay, and that's what I would expect, so that's great. But up here on the collector, I've got something like 7.5 volts, and that's on both of them. Now if I've got 9 volts on the supply, that means there's no headroom in there. It's too near the supply voltage for it to be useful. And I've had a look at the frequencies and that, and why I've put a 47 nanofarad capacitor in there, I've no idea. It doesn't seem to figure in my mind as to why. 100 nanofarads decoupling transistors, don't know. Anyway, I've decided to, what I'll do is I'll connect this up and we'll have a look at it, and then what I've done is I've recreated this again but on the board here, so I can test it, but I've used different values. I've biased it up differently. What I've effectively done is I've changed my 100 nanofarads to 1 microfarad. Is that what I've done? I'm not even sure I've done that. No, that first one isn't a 1 microfarad. It's actually, I bunged in an electrolytic, which is, that is now actually 100 microfarad electrolytic. This is a 1 microfarad, and this is a 1 microfarad, and I've changed these capacitors here to 100 nanofarad, and I've actually got on the output here another electrolytic, which is also a 100 microfarad on the output there, which I don't have on here. Or do I? I think I do actually, but it's a, again, it's a 100 nanofarad. And also these capacitors on here aren't the best ones. Those sort of little ceramic ones, ceramic discs, they're not the best for this type of circuit. I'm sure I could use better, which I'm sure there are around. So on this one I've used these little poly capacitors, which I always find better in my audio circuits. And say a couple of electrolytics on the signal input and signal output sides. I haven't put anything across the power because it's just on the breadboard, so I decided not to do that in this case. If I was going to build it on a circuit, I'd possibly put some across the power to make sure that's nice and clean, but well, I'm sure we'll see what it's like. Now I'm going to power this from 9 volts. I don't know why in this circuit I've put a diode in there. Don't know, perhaps it just seemed to say that I should put a diode in. Maybe it's for protection in case you put the voltage in the wrong way and all the electrons fall out, but you never know. Anyway, now sound. Now I'm going to be using this little gadget that I bought. It's a little kit you can get from the internet. There are loads of them around. It uses the XR2206 function generator. It's a great little kit because obviously I can't put music through and listen to music because all the copyright laws and whatnot. So I'm going to use this to get a sound through it. Anyway, let's get and wire it all up and have a listen. So here we go. I've got it set up now. Speaker, my little function generator thing here set to sine wave. At the moment it's on 100 Hertz to 300. No, is it? Yeah, to 3 kilohertz. So between 100 Hertz and 3 kilohertz. So let's turn it on and see if we can hear anything. Can't hear a thing. Now I don't know if you can hear that. And that's 3 kilohertz. So it's a bit gravelly, but it is producing a noise. So it is doing something, but it's not brilliant. Let's just turn that off. Whew. That certainly gets the ears, and hopefully you could hear that. Let's just change it up. A range. This is now 3 kilohertz to 65 kilohertz, which is beyond the audio range. But let's turn this on and see what that sounds like. At the moment, can't hear a thing because we are way past the human hearing range. But what's that noise? Wow! There's the signal, but there's. Believe me, we're not hearing the signal now because we're beyond the human hearing range. I think we've got a lot of noise in there. Now that's just mad. There's a lot of noise in that. So I think there's the sound coming through, but it's hard to really work with because It's just so damn noisy. Anyway, let's get the multimeter on there, see if I can look at some voltages on there. Let me just get some leads. So I'm just going to plug this straight into over there, so that's my negative, and then I'm just going to probe it round so can I fit it on there. There we go. And have a look at some of the voltages on this and see what they are. So let's turn this on. Let's get some sort of weird sound out of it. No, actually I'm gonna take it back down a frequency range so it's not gonna destroy my eardrums. There we go, hopefully you can hear that. Now, if I can get the pin on it, I want to look at the base of, this is the first one, and this is the second one, over here. So let's see if I can look at the base of the first. The voltage is 1.47, and the base on the second stage is 1.46, so it biased okay on the bass side. But what about the collector? See, there you go, 7.47 volts on the collector side, so there's no headroom in that for a good signal. So that's why I think it's not doing so well. So I've just not biased up very good. But what's it on the other side, on the emitter side? 0.8, yeah, 0.9 of a volt. That's what I'm expecting. That's great. So and that'll be the same for the other one. It's this is ZTX 651. That's the oddity, I suppose, because that bit of an effect on the signal there. The bass is that true? Is that the bass? I think so. 1.19 volts rather than the 1.6 that I'm hoping for. And like I say, I put this 1 meg ohm resistor in here from the emitter, and I have no idea why, because the output there is 0.72, but obviously that 1 meg's going to severely affect the amount of current that's going to be able to go to drive this speaker. Anyway, let's change this over and connect this one up. So here we go, we've got the breadboard version on here, and there have been a few changes. Like I said, I've changed some of the capacitors. I've also changed the biasing for the collector emitter stage of this. I will go back to this drawing afterwards and show you what I've done, but let's have a listen to this this setup now. Ooh, immediately that's louder. Doesn't really amplify much above that, but wow, that is definitely louder. It's a much better amplifier, and all I've done is biased it up a bit better. I suppose the other odd thing about this is I don't need to have 3 transistors. I could really, I think, just have 1 transistor and that ZTX, the emitter follower, in there, or I could just not have the emitter follower and just take it directly out from the 2 transistors. It doesn't have to be 3 in this configuration. That's a bit more than I need as a little Class A preamplifier. And that's definitely loud. Just change it up to the next frequency range. And as you can hear, there's nothing there, and I don't have all that crackle and noise that I was getting from the other ones, because, as I said, from what I've learned about capacitors, these ones, these little ceramic discs, are on here a microphonica, they call it. You know, they can pick up noise from vibration and stuff, and actually affect the signal through the circuit. Whereas on here I'm using the little poly ones. So I've changed the frequency, and as it is on, you can't hear anything. Turn it up, all the way up, still nothing. But if I turn the there, now I can hear it. Definitely, that's really high pitched. That's obviously somewhere in the range of, I know, 15 to 20 kilohertz, which is human audio range. People with good hearing are 20 hertz to 20 kilohertz, and people that are getting older, it's generally somewhat less. But yeah, that's going to set off just tinnitus, I reckon. Oh dear. And that's about 3 kilohertz. Unfortunately, as you may have noticed, I don't have an oscilloscope. This would be great to show on an oscilloscope. I don't have one though, can't afford one. Perhaps I might be able to in the future if I save up all my pennies. But this is a classic circuit where an oscilloscope would really be helpful. But it's working, and it is definitely louder than the board I made previously. Ooh, let's take that down a frequency range, shall we? Now that's supposedly again 3 kilohertz down to 100 hertz. Let's get some volume in that. See, as soon as you turn the volume up, wow, there is definitely some volume in that. So that's a much stronger signal coming through this circuit, just because it's biased better. Well, let's turn that off before I go deaf. I suppose what I ought to do really is shove the multimeter on there and have another look. I think what I'll do is, hold on, let's see if I can fit this in. Move that over, push that down, get it in there. Wrong side. Now, the main thing to look for, I think, is the let's have a look at the bass on these. 0.76 on that one. Getting in there. 1.58 volts on the base of the first transistor. But I have 0.7 on the second transistor, which is a bit odd, so I'm not biasing as well. Excuse me. And then we have the collector voltage, of which on the second transistor, I can get it in there, is 5 volts. A bit clicky there. And on the first transistor it's 4.7. So the biasing on the collector of both of these transistors is much better, to get a much better swing on the signal than on this one, which was at 7.5 volts. There was no headroom on there. And also the capacitance that I was using, I think, wouldn't give me very good gain on this. The emitter is 0.9 on the second stage, 0.93 on the first stage. So the collector emitter biasing is much better, and the output, I'm at about 3 volts, just under 2.9, so that hopefully should carry quite a good signal, because obviously on the other side you don't have that because the capacitor takes out the DC. But we also have on the collector side you have 3 volts, which is the same, which is where we're taking the signal from, because this is an emitter follower. What's my base voltage on that? 1.53. So actually, yeah, no, it works nicely. Just biased up better. Oh, yeah, certainly going to get my tinnitus going, isn't it? So let's have a quick look back at the circuit diagram, shall we? So, like I said, I've made a few amendments to the original design. I have used the same transistors, 2 BC337s followed by a ZTX651. I love this transistor, it's really useful. Can take quite a bit of current as far as small circuits go, so I do like it. Like I say, we don't have this 7.5 anymore. That has come down to, what did I say? Was it 4.5 or approximately, something like that? And that was the same for both of these transistors, so there's much better headroom. And what have I put in here now? I think I've put in here is not a 1K, I've now got a 430 ohm, and down here I've got a 91 ohm, and it's the same on this side as well. So just much better ability to have a voltage swing, and that's about right. It's still about 9.9 of a volt, which is great. That works fine for me. What else can you say about it? This stage here, now this was, that's at about 1.5 volts, wasn't it? Which is great. And then here we had 3 volts, was it? I think so. This transistor is actually dropping 6 volts actually across the transistor, so that'll get a little bit warm, but this transistor is really good, it can cope with that. What more can I say about it? It's just a case of deciding what transistors you want, what's going to be most useful. Do I really need the 3? Probably not. I'll probably just get away with one of them. I could probably remove that part of the circuit and just have that with that following it, and it probably still worked just perfectly fine. It's a Class A amplifier, just needed biasing up a bit better, and using more appropriate capacitors. There you go. Give it a try. Get hold of some stuff like this and do stuff, put different values in. Oh, and I changed this as well. I didn't have a 1 meg in there. I put 150. I put 150 ohm resistor in there, which yeah, why 1 meg? I've no idea. So there you go. Yeah, I mean, take the very basic Class A transistor amplifier, which is basically that bit, which is just one transistor, biasing on the base, biasing on the collector and emitter, so you get a nice mid voltage from the collector, where you're going to have take your output from there, and see what you get. Change the resistors, change the capacitors, see what happens. It's what I've had to do really to get and understand this, and now I understand how to bias this up better. I can realise what I did wrong on that circuit. So there you go, a little circuit, transistor amplifier, basically not biased up properly. And did I use the right transistors? Maybe I could have used better transistors than I have, and all that goes into making a good little Class A amplifier. How you bias it, what transistors you're going to use, what voltage it's going to use. It's going to be from a battery, from a power supply, many variables that when I put that little circuit together I didn't know about, didn't take into consideration, so I ended up with a bit of a ropey little amplifier. Didn't work very well, but now I know better. Anyway, if you like this video, give us a thumbs up, subscribe, and all comments are welcome. See you next time.